Hey guys, Mr. Simpson here. I'm going to hit the highlights on some of Trig Test 4. So I've got the written out solutions up. They've been on Google Classroom for a while. But I want to go through some of these common ones that a lot of people missed, just to make sure we're all on the same page. Okay, so first I'm going to look at number 4. And so what you might notice here is the sine of 90 minus theta, tangent of 90 minus theta, secant of 90 minus theta. So those look a little bit out of place. What we would like to do is try and replace those with something. And so what we can look at back here, sine of 90 minus theta is the same thing as sine of pi over 2 minus theta. So these are the co-function identities. So this means the two angles that we're talking about add up to 90 degrees, or pi over 2. And so in that case, I can switch from sine of 90 minus theta to just cosine of theta. It's cofunction. Same thing with tangent. That can become cotangent, and secant with cosecant, like so, and so forth. Okay, so here we've got sine of theta and then sine of 90 minus theta. So we said sine of 90 minus theta is the same thing as cosine of theta. It's cofunction. Tangent of 90 minus theta is the same thing as cotangent. It's cofunction. And secant of 90 minus theta is the same thing as cosecant. It's cofunction. So all these things are multiplied together. Sine times cosine times tangent times cotangent times secant times cosecant. Now what I'm going to do is rewrite these last three as reciprocals. So write it all in sine and cosine. I guess I could do the same thing with tangent as well. So I'm going to keep sine and cosine the same. I'm going to change tangent to sine over cosine. Cotangent is the reciprocal of that, cosine over sine. Secant is 1 over cosine. And cosecant is 1 over sine. Now I'm going to multiply all these things together and see what cancels out. So to help me with that, I'm going to put sine and cosine over 1. So anywhere I see a sine on the top, I can cancel it out with a sine on the bottom. Cosine on the top, cosine on the bottom. Sine on the top, sine on the bottom, cosine on the top, cosine on the bottom. What's left over? Well, everything canceled out. And so it's not 0, it's going to be 1. When you divide something by itself, it leaves behind a 1, not a 0. There we go. Okay, let's look at another popular one to miss, number 10. So, you notice here you've got a cosine squared, you've got a sine to the first power, you've got a constant term. This is a quadratic equation. Now what we need to do before we solve it is rewrite it with only a single variable in there. So right now we've got cosine and sine both in there. What we can do is replace cosine squared with 1 minus sine squared. Now we're only going to have sines in there instead of both sines and cosines. That's going to make it easier to solve. Okay, so to solve a quadratic equation, you want to move everything to one side, set it equal to 0. So I'm going to add the sine squared to both sides. So that's going to cancel it out over here. I'm also going to add the 1. Actually, I'm going to subtract the 1 because it's positive. So subtract 1 to the 5. Those are like terms, and you'll get 4. So sine squared plus 5 sine of theta plus 5 minus 1, 4. And leave it set equal to 0. That's how you solve a quadratic equation. Now you've got to solve it. So remember we thought about this as being something like x squared plus 5x plus 4, with x representing the sine of theta. So how would you factor that? So this one's pretty easy. The first two things need to multiply together to get sine squared. That's like our x and our x. So those multiply to get sine squared. And when we have just a 1 in the front, the last two terms need to multiply together to get 4 and add to get 5. Ooh, I know. 1 and 4. Like that. So we get our factors there. Now we set each factor equal to 0. So either sine of theta plus 1 equals 0, which would mean sine of theta equals negative 1 if you subtract the 1 over. Okay, that could happen. And what would we get from sine of theta plus 4? Well, we would get sine of theta equals -4. Can that happen? Nope. So we're not going to consider that case. That can't happen. But this can happen. So where would sine of theta equal -1? Sine's the y value. A y value of -1 would be straight down. And on the interval between 0 and 360, that angle is 270 degrees. And that's the only answer there. Let's look at the second page. Okay, so on this first one, we're looking for the tangent value of an angle, and we're looking for the exact value. So your calculator is not going to help there. What we want to do is try and tie this back to one of the special angles that we know. So you might notice that that 175.5 is 315 divided by 2. So our options here when we're trying to find these exact values, we have formulas for the sum of two angles, the difference of two angles, half of an angle, or double an angle. So are there two angles you can add together, two special angles you can add together to get that? No. Subtract? No. Half? Yes. Double? No. So this is our only option. We're going to use the half angle formula here. So the tangent half angle formula. Check the back. Half angle, half angle, half angle. There we go. So here's the tangent formula, and there are actually 3 different ways to write it. It doesn't really matter which one you use, although I think this one is the simplest to simplify. So I'm going to use that. So tangent of theta over 2, here theta would be the 315 divided by 2 equals 1 minus cosine of 315 over sine of 315. So that's the formula we're going to use. 1 minus cosine of 315 divided by sine of 315. Now, cosine of 315, sine of 315, those are values we can actually evaluate exactly based off of the unit circle. So that's why we use this formula. And cosine of 315, right there, that would be the 45 degree angle. It's 45 away from 360, so we're going to have a cosine of positive square root of 2 over 2 and a sine of negative square root of 2 over 2. So 1 minus cosine, which is square root of 2 over 2, divided by sine, which is negative square root of 2 over 2. Now, we've got to simplify this, and of course, you know, on the top, you've got to get a common denominator, so rewrite 1 as 2 over 2. And you'll get 2 minus the square root of 2 over 2. So that's subtracting those two. Once we write the 1 as 2 over 2, that gives us a common denominator. And that'll all be over negative square root of 2 over 2. Now, we've got a fraction over a fraction, so instead of dividing by the fraction, flip it and multiply. So multiply by negative 2 over the square root of 2. You can distribute there, and you can follow through the rest of the simplification. So distribute on the top, multiply that on the bottom. You can follow through the rest of the simplification from the written out solutions. But once you've gotten this far, you've gotten most of the credit already. You just need to write it without a square root on the bottom. Okay, 13, cosine of 165. So again, we want to find, since 165 is not one of our special angles, some way to build it out of a special angle. So maybe add a couple together, maybe subtract a couple, maybe cut one in half, maybe double one. Now, we could use the half angle formula here, because 165 is half of 330. But the simplification on the half angle formula is maybe a little bit trickier than on the sum or the difference formulas. So I would like to try to build it out of one of these if I can. And I can't, because 165 is, say, 120 plus 45. And that's by no means the only way to break that down, but it's at least one way to do it. And so we need the cosine formula for the sum of two angles. Alright, sum and difference formulas. Cosine of a sum, there it is, right there. That's the formula we're going to use. So cosine is cosine, and there's a minus sign in there. All right. So we're going to do cosine of 120 times cosine of 45 minus, because it was in the formula, sine of 120 times sine of 45. Now we're just going to plug in all these values and simplify it. So what's cosine of 120? Ooh, let's see. That's right there, closer to 90 than to 180. So cosine would be the short value, which is 1/2, and it's negative. So negative 1/2. Cosine of 45, square root of 2 over 2. Minus sine of 120. Here's 120. Sine would be the long leg of the triangle there, so that's the square root of 3 over 2, and it's positive. But because we have this minus sign here, our answer is going to be negative. And then sine of 45. Here's 45. The sine is the square root of 2 over 2. Now, how do you multiply fractions together? Well, you multiply straight across the top, straight across the bottom. So on the top, we're going to have a negative 1 times the square root of 2, which is negative square root of 2. And on the bottom, 2 times 2 is 4. Over here, we've got a minus, and then we've got square root of 3 times square root of 2. Because they're both underneath the square root, we can multiply those together and make it a square root of 6. And on the bottom, 2 times 2 is 4. Now I have two fractions that happen to have a common denominator, and so I'm going to add them together and get negative square root of 2 minus square root of 6 divided by 4. There's my exact answer. So if you can, try and use the sum or difference formulas, because the simplification is going to be a lot simpler than it will be using the half angle formula. Okay. Let's jump down to 17. So we want to find tangent of 2 theta. Now, 2 theta would be this big angle right here. So I don't know the opposite and adjacent values for the angle 2 theta, but I do know the opposite and adjacent values for the angle of theta, which is half of that. That's 6 as the opposite and 8 as the adjacent. So if I can tie this back to the original theta angle, then I can use its tangent value. And I can do that using this double angle formula. So tangent of 2 theta is 2 times tangent of theta over 1 minus tangent squared. That's the formula I'm going to use. So that's 2 times tangent of theta over 1 minus tangent squared of theta. Okay. Now, what's tangent of theta? Well, here's theta. So in this triangle with theta, we've got a 6 as the opposite and an 8 over for the adjacent. So tangent of theta is 6 over 8. So everywhere I see tangent of theta in this formula, I'm going to put in 6 over 8. Great. Now all I have to do is multiply some stuff together and simplify. So how do I multiply 2 times a fraction? Well, think about this as 2 over 1. Multiply straight across. The 2 only gets multiplied on the top. So that's 12 over 8. And then on the bottom, I need to square this fraction. So I square the top, 36, square the bottom, 64. Now I have to rewrite this 1 to have the same denominator. So 1 is 64 64ths. Now I'm going to subtract on the bottom. So I still have 12/8 on the top. So how many 64ths is that? Let's see. 64 minus 36 would be 28. So 28 64ths. And now I'm going to flip and multiply. So multiply by 64 28ths. Now, at this point, it's going to save me a lot of trouble if I can reduce that fraction ahead of time before I actually multiply those numbers together, and then I have really big numbers and I don't know what the factors are. So I see here I've got an 8 and a 64. Well, the 64 is on top, the 8's on the bottom, so I can reduce those. I can divide them both by 8. That 64 would become an 8, and the 8 would become a 1, because I divided them both by 8. And I can also reduce this 12 and this 28. So the 12 and the 28 are both divisible by 4. That would make the 28 a 7. That would make the 12 a 3. So I've got 3 over 1 times 8 over 7 after reducing, which gives me 24 over 7. So it's always easier to reduce ahead of time when you're trying to multiply two fractions together. Okay. Let's look at number 18 now. So we just learned that tangent of 2 theta is 24 over 7. Now, we also know that we're trying to solve for y here. So in this triangle that has 2 theta as an angle, we've got the y over here and we have the 8 over here. Alright, so I know that to solve for y, I can use tangent of this angle 2 theta, and it would equal the opposite, y, over the adjacent 8. Now, if I knew what angle this was and I could just type in my calculator and get a tangent value, I would know how to solve this. But I don't know what the angle is. However, I do know the tangent value because I just found it. It's 24/7. So that's like if I typed it in my calculator and it told me 3.5 or something like that. So we're going to use that value as the tangent value, even though we don't know the angle. We don't need to. And that's equal to y over 8. Now all I have to do is solve for y. So to do that, I'm just going to multiply by 8 on the other side. So y equals 8 times 24 divided by 7. So that's 192 over 7, which is about, I don't remember, 27.4, I think. Maybe 24.7. I don't know. You've got a calculator. Okay. Let's look at number 20. So, in both of these bottom two questions, you're given some information about a triangle. And by the way, yes, you do need to know how to do number 20 for the final, even though I didn't grade it. Any of these questions are fair game. So, make sure you look at them all. So number 20, we're given that tangent of some angle is negative 17 divided by 10, and the angle's in quadrant 2. So I'm going to draw this like it would be facing in quadrant 2 just to make this a little simpler. So quadrant 2 is up here, so my triangle is going to be facing this direction with my angle over here. Okay. So tangent is opposite over adjacent. So I've got a 17 and a 10. Now if I'm in quadrant 2, which of those is going to be negative? The 17, which is the height, or the 10, which is the width? It's going to be the 10. So 17 divided by negative 10 is negative 17 tenths. The negative can go on either one. You've got to decide from the quadrant. So I've got a 17 and a negative 10. What would my hypotenuse be? Now, even though I drew this in the unit circle, it's not going to be 1. We can use the Pythagorean theorem. So 17 squared is 289. 10 squared is 100. Add those together, that's 389. So this side is going to be the square root of 389. What's that? Well, it doesn't matter. It's not an exact value, so we'll just leave it as the square root of 389. Exact value, leave the square root there. So, what's sine? Now we've done all the hard part. Sine is just opposite over hypotenuse. So opposite from this angle would be 17. And the hypotenuse would be the square root of 389. And you'll notice it's positive because the fact that we're in quadrant 2 told us we've got a negative cosine rather than a negative sign. We've got a positive sign, we would have a negative cosine. I didn't ask for the cosine. I asked for sine and cosecant. What's cosecant? Well, it's the reciprocal of sine. So the square root of 389 over 17. Now, one of these is okay to leave the way I have it written. One of them is not. You notice this sine value has a square root on the bottom. So let me fix that. So how do I fix that? Well, I'm going to multiply by the conjugate, which would be the square root of 389. Which gives me 17 square root of 389 over, that times that would just be a regular 389. So that would be my sine value simplified and reduced. Last page. Okay, so I'm going to hit some highlights on this last page as well. Number 2, cosine of negative x. So this would be a y-axis reflection, a horizontal reflection. Because cosine is odd, or it's a ghost. Because cosine is odd, when you flip it across the y-axis, it's the exact same. So some of us flipped it across the x-axis instead. This is a y-axis reflection, so it's going to be the same. Now, when I graph it, I want to make sure I label some things. So I want to put a 1 and a negative 1 so that I know where the top and the bottom of this are. And I want to put some angles, so I'm going to count by pi over 4. So 1, 2, 3, there's